Okay. You know how you can't have negative exponents? And you can't have fractions inside your fraction? You also cannot have square roots inside your denominator. It's just not allowed. So to get rid of the square root in the denominator, you square it, basically. But if I multiply the bottom by the square root of 14, I also have to multiply the top times the square root of 14. So this gives me, hold on, the square root of 294 over 14. And now I need to see if I can simplify 294 at all. So I'm going to make a factor tree. I know it divides by 2. And that gives me 147, which is 12 if I add them together. So I know it'll divide by 3. Whoops, no. Which gives me 49, which will divide by 7. And so I do have a perfect square in there. So this is 7 times the square root of 6, because the 2 and the 3 stay. And that's over 14. And then the 7 and the 14 will reduce. So I end up with the square root of 6 over 2. And now you can't reduce this 6 and this 2 at all because the 6 is under a radical and the 2 is not. So don't try to do that. You can only reduce things that are outside the radical. Okay, so to get rid of this square root of 2 in the denominator, I'm going to multiply times the square root of 2. And this will give me the square root of 34 over 2. 34 is 2 times 17. So nothing can come out of here, and so I can't reduce it. So this is my final answer. To get rid of an 11, you multiply by an 11. And 6 and 11 don't reduce, so I'm done. So you just have to check, can I take anything out? And then once I've done that, can it reduce? Or here I can't take anything out, so nothing will reduce. And here I had that 6 on the outside, but the 6 and 11 don't reduce. But if this was maybe, say, a 12 or something, I could reduce it.